Last time we answered the first question, where we said that digital signatures can be used so that the name server signs the record with their private key and everyone else verifies with their public key. So here's our second design question. When someone sends you a record, how do you know that the record is correct and that nobody has tampered with it? So how do you actually use digital signatures to check if a record is correct? We know the scheme we want is digital signatures, but how is it actually used? So remember, with digital signatures, one person with the private key can sign, and everybody else can use the corresponding public key to verify. So a natural person to give the private key to would be the name server. They're the one that creates the record, so they should have the private key to sign the record, and nobody else in the world should know that private key. However, the public key of the name server should be known by everybody so that everybody can verify the record, and that's how you use digital signatures. So we decided on a protocol to use, or a cryptographic primitive, and then we decided how to use it. So with those two ideas, we can already start to figure out what DNSSEC is going to look like. As always, the recursive resolver asks the same question we've always been asking. What is the IP address of eeks.berkeley.edu? But the question for you now is, what does the name server have to return in order to use the digital signature scheme that we've been talking about? So it was no longer enough just to say, here's the answer, it's this IP address. We also have to include some extra data. So in English, what would that data look like? I can think of 3 things we need, so you can try and predict what they are before I show them. So the 3 things I think we need are the record itself. That hasn't changed. We still have to say that the IP address of eeks.berkeley.edu is some sequence of numbers. What else do we need? Well, we just said that when a name server sends a record, they will use their private key to sign the record so that we know it came from them and nobody can tamper with it. So in addition to the record, you'll also send a signature over the record. That's 2 things. But there's actually a 3rd thing we need too. Think about what the recursive resolver does when they receive this record. When you receive the record, how do you know if the record is correct? What did we say earlier that we have to do with the record and the signature? Well, I have to verify the signature, and to verify the signature, I need the public key. So the 3rd thing I need is the public key of the name server so that the recursive resolver can use that public key to verify the signature. So those are the 3 things we need. Good job if you predicted them ahead of time. This is what it might look like in English. First, there's the answer record. That's the same as it's always been in normal DNS. Then we say, here's a signature on the above record. And finally, we provide the berkeley.edu name server's public key so that the signature can be verified. So with these 3 values, we can give the record to the recursive resolver, and they can verify that the record hasn't been tampered with.